Okay, so the next topic has to do with finding these asymptotes, both the vertical asymptotes, that's where the graph sort of shoots up suddenly or shoots down, and then the horizontal asymptotes, which correspond to the end behavior. So to find the vertical asymptotes, it's really about finding where the denominator is 0. And the only caveat is you have to make sure that the rational function is in lowest terms, which means that that there are no common factors between the numerator and the denominator. Once you cancel all the like factors, then you can just go set the denominator equals 0 and go from there. So the key here is you want to factor, do as much factoring as you can. For example, and just before I get into the examples, in short, if this is in lowest terms, the x-intercepts are where the numerator is 0, and the vertical asymptotes are where the denominator is 0. So in example A, you can see that this factors as x plus 3 times x plus 1, x minus 1. Okay, obviously none of the factors cancel, and so we just go and say, okay, set this denominator equals 0, and we can see that it will be 0 at negative 1 and 1. So the vertical asymptotes will be at x equals 1 and x equals negative 1. In part B, so already factored, as you can see there are no common factors, nothing cancels. Set each factor in the denominator equals 0, and you see the vertical asymptotes will be, we'll set x plus 2 equals 0, you get x equals negative 2. Set x minus 3 equals 0, you get x equals 3. Part C is when things get a little different. We can factor out an x from the denominator, and we get 3x plus 1. Okay, so this is not in reduced terms because we can cancel out the x's, and this becomes 1 over 3x plus 1. And then that's in lowest terms, or in reduced form. So then you set 3x plus 1 equals 0. You get x equals negative 1/3. And that's the vertical asymptote. Okay, x equals 0 is not going to be a vertical asymptote. And let's look at part D. Looks like we have to factor again. So okay, you can see the factors. Looks like x minus 2 times x plus 1 will be the factorization of the top, and x plus 3, x minus 2, that will be the factorization of the bottom. We can see that the x minus 2's cancel, and so this becomes x plus 1 over x plus 3. Okay, and set the denominator equals 0, and you get the vertical asymptote will be x equals negative 3. So that's basically how you do for finding the vertical asymptotes. It's not too bad as long as you're in reduced form or in lowest terms. Now, to find the horizontal asymptotes, it's also a pretty straightforward process. The idea here is every rational function can be put in this form, and we know that in each polynomial the leading terms determine the end behavior. So this leading term is going to dominate all the other terms up here. This term will dominate all the other terms down here. So we really just have to pay attention to the leading terms. And so then it just is about, well, which leading term changes fastest. And we just look at the degree. So if the degree of the bottom is bigger, that is, if n is bigger than m, then the horizontal asymptote is going to be y equals 0. That means the graph is going to be hugging the x-axis at both ends. And the reason for that is this denominator is going to get much bigger than the numerator will. So there's a race, and the denominator wins the race. If the degree is bigger in the numerator, that is, if m is bigger than n, there's no horizontal asymptote because the numerator is changing faster than the denominator, and that means if there's no horizontal asymptote, the graph is shooting up or shooting down. And then if the degrees are equal, we look at the leading coefficients and we divide them, and then that's going to be where the horizontal asymptote will be. So you only look at the leading coefficients if the degrees are the same. Okay, so that's, in short, when finding the horizontal asymptotes, always look for the degrees of the in the numerator and denominator first. Okay, going back to our examples, in part A, the degree of the bottom is bigger. This is 2. This is 1. So y equals 0 will be the horizontal asymptote. Part B, I think we can see the degrees will be the same. If we were to multiply this out, this would be minus 3x squared plus some other terms because of the minus x here. And then if we multiply this out, we get x squared plus some other terms. So the degrees are the same. The leading coefficient up here is negative 3. Down here it's 1. So y equals negative 3 is the horizontal asymptote, which is the same thing as negative 3 over 1. That's how we get that. Part C, we see here the degree is 3. This degree here is 2. So there's no horizontal asymptote. Part D, we look, here the degrees are the same again. So again, we just look at the leading coefficients. And so the horizontal asymptote here is y equals 6/5. Now, for E and F, it's going to be a little bit different, but not too much. You can still combine this into one, you get using a common denominator. You can take the 3 and write it as 3x squared over x squared. So this will become 3x squared over x squared plus 1 over x squared, which is 3x squared plus 1 over x squared. So the degrees are the same. So the leading coefficient is 3. Here it's 1. So the horizontal asymptote is y equals 3. Another reason you can see this is because as x gets really large, this 1 over x squared is going to go to 0. So this will be, the value of r of x is going to be more and more like 3. And since the y, we're looking at the graph of y equals r of x, so y is going to be approaching 3. Here, you have to be a little more careful because this x is getting large and this 4 over x is getting small. So what we do, we really want to combine this using a common denominator. So this will be x squared over x plus 4 over x, which is x squared plus 4 over x. And here the degree of the top is bigger than the degree of the bottom, so there's no horizontal asymptote. So it's really all about comparing degrees.